All right, so let's run through a couple application questions, just kind of get an idea of the basic run through of them. And so this is section 6.2, and what we're going to see here is that the standard normal distribution curve can be used to solve a wide variety of practical problems. The only requirement is that the variable has to be normal, or approximately normally distributed. So let's just put this out here, okay? Now, there's going to be a question about, is this data normal? But we'll address that in a little bit. But what I want you guys to understand at this point, from here on out, if somebody says the data is normally distributed, then you can apply these properties. The whole z-score, the whole process of going through, the whole normal distribution curve, table E, that stuff applies. You can use it. So from here on out, we know that in chapter 6, that applies. It's understood. So we go back to the z-score one more time. We're going to use this. Okay, so now with that little introduction of z-score I did in that video, now we see, okay, here it is. We're going to apply it. So we're going to be using this each time. All right, so here's our problem. So the biggest thing I think that comes across is, oh my gosh, this is a word problem. Okay, so what I want you guys to keep in mind is this for me. You know you have to find a z-score. Okay, so we know right away on these problems we have a z-score, and so I'm having some technical issues. Let me hit pause for a second. All right, so remember, if we're going to use the z-score, we know that the z-score is composed of the data of whoever we're talking about, their particular score. So like if it's a patient, it's their height, it's their weight, it's the amount of blood, whatever it is. We have our mean, and we divide by the standard deviation. So in this formula, we know that we might be given a z-score, we might be given an x, we might be given a mean, and we might be given a standard deviation. So utilizing the fact that we know that those are the things that we're looking for inside of this problem. All right, so let's go ahead and read through this guy real quick and see what we got. All right, so the normal average, an adult has on average 5.2 liters of blood. So there's a number, average is the description. So we go down our list right here and we get 5.2 liters. Assume that the variable is normally distributed, so there's that statement. That statement right there is the one that specifies this is normally distributed, therefore you can apply the properties of the standard normal distribution curve. It has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters. So there we are, people 5.4. That's our data value. 5.4. That's our x value. So we're trying to find a percentage. Remember, percentages come from z-scores. So z-scores are what I'm going to have to find, and then I'll have to go find my percentage. There's one more piece on here, less than. So we've done problems to the left, we've done problems to the right, and we've done problems between. So if we're doing less than, then we have area to the left. So we go back through our notes and we're going to apply the properties of what did we do when we found the area to the left. So let's set up our z-score. Our value is 5.4 minus 5.2 divided by our 0.3 for our standard deviation. So we get 0.2 divided by 0.3. When we divide that out, we get 0.666666666 repeating. Okay. Remember that in our table E, we only need 2 decimal places. So we're going to round this guy to 0.67 because this 6 right here, since it's bigger than 5, it makes that number go up to 7. So our z-score that we're going to use is going to be 0.67. So we come on back here, we have a z-score of 0.67 on our table E. We grab our straight edge, we do our 0.6, We do our 0.07. This gives us our two numbers together. And we find out that the corresponding area, or the percent of area under the curve for that particular z-score, is 7486, which remember is also known as 74.86%. So give me 1 second, we'll go back to the other page. So what we see here is that we come back over and we find out that find the percentage of people who have less than 5.4 liters of blood. So we find out that the area under this curve, the percentage of people in this particular study that would have less than that would be 74.86%. Okay, so that's how we apply using our standard normal distribution curve to actually use it inside of a word problem scenario.